Hey guys, we're back. So we are going to look at a figure that you probably haven't heard of called ellipses. Okay, that's how you spell it, ellipses. And you can kind of see it's kind of like, if you want to say like a football shape or an oval. Probably the word oval is what it's the same. An ellipse is like an oval. Okay, so really, if you think about that word, you've probably heard the word oval, but in math, the name we use is ellipse. Okay, ellipses. So we're going to talk about ellipses. Now, obviously, there's just mathematical facts on this, but a lot of the practical uses of ellipses is reflecting light or reflecting sound. So I don't know if any of you guys have ever been to Blossom Music Center for a concert. But even other stages, even indoor stages, they will sometimes try to make the back of the stage rounded, kind of like an ellipse, because it reflects the sound out from that circular. Obviously, you would only have like half an ellipse. And actually, on the next video, we're going to use a practical example of a sound center that has an ellipse, and that's actually the problem on our exam that we're going to learn. Okay. Now, I just want to show you some facts about an ellipse, and then we're going to actually solve some things related to that mathematically. To start with, though, obviously there's still a center. There is a center in the middle of the ellipse. I mean, kind of halfway between there, halfway between there. Now, if I do a dotted line vertically through that, I actually can go through the center, okay? And I obviously have like vertexes or vertices on each side. Now this is the short distance, okay? And then there's also vertices that go across the middle, okay, the long distance there. Okay, now there's some more details. Some of you that go on to calculus in college and stuff, you'll learn more about this. For our class, we're just kind of introducing some of this. Now, the thing that's kind of practical here is in an ellipse, in the long direction, okay, it's not in the short direction, but in the long direction, there is a focal point, focus, which, again, some of you guys in science, you might have worked on that, like concave and convex, mirrors and stuff like that. It's really the same idea. There's a focal point. And again, it's a certain distance here, but it would be like right here. Okay, which means that distance from here would be the same here. Okay, right there. That's a focal point. Let me grab another color. Okay, what that means, guys, is if I had a sound or light and it shot up to here, if it shot up to here, it would reflect, or the sound would go right down to the other focal point. That marker's dry. Bummer. Okay, let me use my blue. Okay, so again, if I went up to that dotted line right there, it would bounce, again, if it was light or sound, from this focal point. Again, it's a focus point of the sound. It goes up, and then it'll come right back down. It would like bounce. I mean, that's really what an ellipse is special that way. Light would bounce, sound would bounce from one focal point to the other. Okay, anywhere along this ellipse, there's these focal points are where things like bounce to each other. Now, obviously, we're going to stick numbers in here, solve for things. Okay, one of the big important things is, guys, because these are crisscrossing, all of these corners are like 90. So 90 here, 90 here, 90 here. So these are all 90. So if you look, I mean, what I have right here is a right triangle, don't I? 90 in the corner. So if I think about this right here, and that distance to the focus is like my hypotenuse. So remember, if I have information with a 90-degree triangle, we can use a squared plus b squared equals c squared. Remember that? So again, that's the application here. okay, is taking numbers and solving them using a squared, b squared, c squared. Okay. Now, again, let me just take, again, we're just looking at a general ellipse here. Okay, I already drew it. Now, you can see this one's standing up. So, obviously, this is the long direction. Instead of it sideways, it's standing up. There's my focal point. There's my focal point. Okay, there's my axis across there, axis across there. Okay, and here is that distance right here. Okay, there's my distance. Okay, and I'm going to give you some information, and this is what it's going to be like on your homework. Okay, so let's say that the focal point to the center is 3 centimeters. Okay, what's interesting, so obviously, guys, this one here would also be 3 centimeters. Okay, so again, the distance from the center to each focus point is always the same. So if that's 3 centimeters, that's 3 centimeters. Okay, now let's say that this one right here is 4 centimeters. Now obviously that distance right there is for this triangle or this triangle. And remember, guys, we just said it. This is 90 right here. Remember, that's like a 90 degree. I can put that little block in there. That's 90. Okay, so the questions are going to be, how far is this reflection or that sound bouncing off? How long is that? Well, what we can do is find this distance right here using a squared, b squared, c squared, because remember, guys, that's my hypotenuse. Remember, hypotenuse is the c. So we're actually going to use 3 and 4 to solve for my hypotenuse, the c right there. Now, again, this is really pretty easy. I'm giving you a pretty simple one. I mean, you can get decimals for these. Obviously, I'm just going to give you some that aren't decimals. Okay? But one side is 3. One side's 3 plus, okay, b squared. I can let b squared be the 4 right there. And I'm going to solve for that distance c right there. Okay? Now, again, I'm giving you one that's pretty easy to do on the calculator. 3 squared, remember, guys, 3 times 3. 3 times 3, not 3 times 2. 3 squared, 9, plus 4 squared, 16, equals c squared. 9 plus 16, again, I'm giving you an easy one. 9 plus 16 is 25. Remember, anytime I'm trying to solve for c and it's got a square on, or any variable, and it's got a square on, remember, the inverse is square root, so I'm going to square root, which cancels. Whatever I do to one side, do the same to the other. So c is by itself. Square root of 25 is 5. And guys, that's right there. This distance would be 5 centimeters. Okay? So the distance of that reflection. So the sound, though, totally, so again, that's 5. This one over here would also be 5. So really, the focus bounces off really a distance of 10. Because 5 and 5, okay, that's going to be something we're going to do on the next video, is actually take a story problem, a picture problem, and find the distance the sound travels. Okay, so actually in this problem, if there was a speaker here and it bounced off the ellipse and went to the other focus point, how far did it go? It went 5 and 5, it went 10 centimeters. Okay, now again, we're talking about centimeters, which is pretty small. Okay, obviously, if I'm talking about the sound, that's going to be like feet or meters, whatever. Okay, so anyway, guys, that's what we're doing. Okay, now look at the problem here. Okay, we've got 8 from the center out to the focus point, and then we got 6 from the center out to that vertex. And then I want you to find, if you can tell, I want you to find x. So we're trying to find that dotted line. How long is that dotted line x right there? Okay? So see if you can apply that and find the distance of x. What's nice, guys, it's going to come out without a decimal. So it's kind of nice that way. Okay? You won't get a decimal if you do it right. Okay? Okay, guys. Thanks. See you next time.